Okay, for this analysis, we have certain to make certain assumptions that our signal variation, AC variation, is small compared to your quiescent condition. Okay, that means suppose I am selecting base current. This is my input characteristics, base current. You have a linear region and over. So this is our operating point IB. So when you apply an AC signal, that AC signal will be superimposed over this DC quiescent condition. So what we are trying to do is we are limiting the region of operation to a linear region. Actually, the base current versus voltage, okay, that is a nonlinear thing. It is exponential. But if you consider a small region, it can be approximated as a linear region. And for this to happen, AC variations should be less. So that is known as a small signal linear device. And frequency of operation is less. Right now, I am considering only low frequency condition, and inter-electrode capacitances are low. That is in the picofarad region. Well, what is the significance of all these assumptions? The first one we have seen here. And regarding the frequency, low frequency condition and inter-electrode capacitance being low, they are interconnected. At higher frequencies, you know that the capacitance reactance XC is equal to 1 by 2 pi FC, and that XC will become less, so that you cannot neglect the inter-electrode capacitances. So the total XC is inversely proportional to frequency. It is also inversely proportional to capacitance. So if these two are low, then XC can be very large. So you can neglect it. So that is the condition. So what are we trying to do? You are modeling transistor as a simple passive device. Okay, so this is our transistor, and you call it as a two-port connection, two-port device. You are considering transistor as a two-port device. What do you mean by port? Port means one end where you are giving input, and at the other side you are taking output. So I stands for input side, then R means reverse, F stands for forward, and O stands for output. Okay, this we'll see. So this box is the transistor. It has one input side and output side. So port 1 is the input, and port 2 is the output side. So at the port 1, you are applying a voltage V1, and you find that current is flowing into the transistor. Just like in any system, when you apply an input voltage, then current will be flowing into the transistor. Now, at the output side, right now we have not technically speaking, port 2 is the output side, but for the time being, you are calling it as a port 2. So at port 2, if we apply an external voltage, okay, I repeat, if you apply an external voltage V2, that will make current I2 to flow into the transistor. So, and both sides, whether it is port 1 or port 2, what we are doing is you are applying a voltage at the port, and current is flowing into the transistor. So the direction of current is very important. So at the port 1, you can write equation as V1 is equal to H11 I1 plus H12 V2. So for this, you will assume that when V1 is given, V2 is not there. And when you write about V2, okay, so that is the assumption we make. So V1 is equal to H11 V2 I1. So that is the current flowing. So you H11 I1 plus H12 V2. Likewise, the other port 2 I2 is equal to H21 I1 plus H22 V2. So what is H11? From these two equations, you can write as H11 is equal to, H stands for hybrid. Okay, H means it is hybrid. H11 is equal to V1 by I1 when V2 is equal to 0 and output port is shorted. Okay, so output port is shorted, that to make V2 is equal to 0. Now the next term is H12. So H12 is equal to V1 by V2. How will you get H12? You have to put I1 is equal to 0. Then you will get H12 is equal to V1 divided by V2. So V1 divided by V2 when I1 is equal to 0. So how, when you make I1 is equal to 0, it means the input port is open. Now, the second equation, first term is H21. H21 is equal to, how will you get H21? For that, you make V2 is equal to 0. So you are short circuiting. This is equal to 0. When you short circuit V2, you will get, this term will go. So H21 is equal to I2 divided by I1. So I2 divided by I1 when V2 is equal to 0 or output is shorted. And the last term is H22. H22, you make I1 is equal to 0. So you are open circuiting input side. Then H22 is equal to I2 divided by V2. So for that, you are making input current is equal to 0. I1 is equal to 0. So let us come back to the this parameters again. So H11 is equal to V1 divided by I1. Okay, so that is voltage divided by current. So that is a resistance part. And the subscript of voltage and current are 1, which means we are dealing with the input port, port number 1, which is treated as input. So you can put it as HI. The second term, H12. H12 is equal to V1 by V2. See, whenever you have a system and you are applying an input voltage at port 1, you expect a communication to go in one direction, that is a forward direction from input side to output side. But here what we are doing is you are finding V1 divided by V2. Okay, so it is input voltage divided by output voltage. So we are going in the opposite direction. So you call it as reverse. Now H21 is I2 divided by I1. So what is input current, output current I2 when you gave I1 at the other side? So it is the effect of some current at the input port. So I2 means it is the current at the output port, and what we are trying to find is the effect of input current at port 1. So it is a forward direction from input to output. Whereas in H12, that is the reverse direction. You are finding what is the effect on V1 because of voltage applied at V2. So that represents HR. R stands for reverse, and HF means it is the forward direction. So it is I2 by I1. And the last term is H22. H22 means what is happening at the output port, port number 2. So it is I2 divided by V2. I2 divided by V2 means it is an admittance part, and it is the output port. So the subscript is CO. So I stands for input port and O stands for output port. And R stands for the direction. It means from output to input side. And F stands for forward direction from input to output. Now, why these parameters HI, HR, HF and HO are called the hybrid parameters? Why are they called hybrid? Because the first one is resistance, second one is voltage ratio, that is a reverse voltage ratio, HF is the forward current ratio, and HO is the admittance. So the unit of all these parameters are entirely different. First one you have in ohms, and the last one you have in mho, that is per meter. 1 by ohm, and the other two are ratio of current and voltages. So there is no unit at all. So it's a mixture of things. So you call it as hybrid. So using this parameters, you can draw equivalent circuit of transistor. See here, purposefully I have shown it in two colors to show the input port and output port separately. See earlier, see the transistor, that box I have shown a dotted line. So what you have on the left side is the input side, and on the right side you have output side. So here also that dotted line is shown. So at the input side you have V1 is equal to H11 I1 plus H12 into V2. So that corresponds to the first equation. So it is in terms of voltage. So you have a Thevenin equivalent. So you have a series connection. Now coming to the second equation. What was the second equation? Second equation is in terms of current. So when you have in terms of voltage, you have Thevenin. And when you have in terms of current, you have Norton. So it is the Norton equivalent you have. So I2 is equal to H21 I1 plus H22 V2. So it's Norton equivalent means it is a parallel connection. So that is the output side. So this is the equivalent circuit of a BJT. Okay, transistor means we are talking about BJT. Is that much clear? Can somebody please respond? Say yes or no.
Yes, ma'am.
Okay. So now let us consider a common emitter configuration. So we have a transistor here. Common emitter means emitter is grounded. We are giving input at the base and output at the collector. So input current means it is a current flowing into the base terminal, that is base current IB. So that will correspond to our I1. Here I1 is the input current. So in case of common emitter, it is IB. And what is V1? V1 is the voltage applied between the input port, that is the input point, and the ground. So here base is the input point and emitter is common ground. So VBE, that is the input voltage, which is equivalent to V1. So that is what we are drawing here. Now, what is the next term? H12. H12, it is the reverse thing. So it is HR. And for all the parameters, you add the subscript of configuration, meaning this is common emitter. So HI is E is also added. So HI will become HIE. HR will become HRE. HF, it is HFE. HO, it is HOE. Okay. So H12, V2. And what is V2? V2 is the voltage at the output side. So output port is collector and emitter is the common thing. So the voltage between collector, VCE is the output voltage equivalent to V2. So you substitute that here, HRE into VCE. Now coming to the output side, H21 into I1. I1 earlier itself we found that it is equal to IB, and H21 is the forward current ratio, which is HF, and you add subscript E to indicate it is a common emitter configuration. So HFE into IB. Now H22, that is admittance at the output side, HO subscript E, HOE. Again V2, we already know it is VCE. So you add that as VCE. So this is the hybrid or equivalent circuit of common emitter configuration. Okay. So we can define just writing in terms of the base emitter and collector. We'll find the parameters. HIE is equal to input voltage V1 by I1. So here it is VBE divided by IB. And what do you have to make? V2 is equal to 0. So when VC is equal to 0. HRE is H12, that is equal to V1 divided by V2. So V1 is VBE and V2 is VCE. So it is VBE divided by VCE when I1 is equal to 0 or IB is equal to 0. HFE is equal to I2 divided by I1, collector current by base current when VC is equal to 0. That is V2 is equal to 0. HOE is equal to IC divided by I2 by V2, IC divided by VC when IB is equal to 0, I1 is equal to 0. So these parameters will be given in the data sheet. Now, I want you to remember this part clearly. What is the meaning of this? HFE. HFE is equal to collector current divided by IB when output voltage is equal to 0. When will output voltage become 0? When output port is equal to short. Okay, V2 is equal to 0. That port is equal to, that means there is no load resistance. You have shorted it so that maximum current will be flowing. So that is the meaning of HFE. Because later on you will need that knowledge. So how can you draw a common base configuration? The equivalent circuit is the same. You have input resistance, then reverse voltage, forward current, and output admittance. The only difference is you have to add the subscript B. So it is, instead of HIE, it is HIB, HRB. And what is the voltage here? So common.
ലാറ്ററലിന്റെ സ്റ്റുഡൻസിന് കയറാൻ പറ്റുന്നില്ല, അവർക്ക് കുസാറ്റ് മെയിൽ ഇല്ലാത്തതുകൊണ്ട് അപ്രൂവൽ വെയിറ്റ് ചെയ്യാം.
ഓക്കെ, ഇവിടെ കാണുന്നില്ലല്ലോ. ഓക്കെ, okay. So how will you draw common base configuration? In common base is ground, that's why I call it common base. Emitter is input and collector is output. So this reverse voltage you have to write as HR into V2. So V2 means it is the voltage between collector and base. So this will be equal to VCB. Okay. So HIB into IE, input current is IE. Then you have HRB into VCB, output current HFB into input current is IE. Then HOB into VCB and output current is IC. So you can write equations accordingly. Now common collector configuration means collector is grounded. Collector is grounded, base is the input point, and emitter is the output point. So you have to write the subscripts accordingly. So output voltage will be, input voltage VCB will be equal to HIC. You are changing the subscript like that. Okay. Now what we have to see is, so you know that this transistor, in this equivalent circuit, what we have done is you are converting the transistor into a passive device. You have some resistance. Here resistance is there, then admittance is there, then you have a voltage source and a current source. So you have converted in that form. So how can you analyze a transistor amplifier circuit using this equivalent circuit of transistor? So this is a simplest way of representing an amplifier. So what do we have? You have a transistor which is considered as a two-port network. That is what we have seen earlier. So that two-port network will be having a V1 applied to it. I1 will flow through it. Output of that two-port network is V2 and current I2 is the flowing into the transistor, the same as earlier thing. So what you have between these two blue lines is the equivalent circuit of transistor. Okay, so how can you give? You need to connect an external source. So a source is given. See, whenever source is given, you put the subscript S. Vs means it is a voltage source. And every voltage source will be having some internal resistance. So this comes together. For analysis, we have showing them separately, but actually it is a single unit. So the source voltage is there, source resistance is there. And that is connected to the two-port network. And at the output side, to get the amplified signal to a load, we are connecting a load that is denoted as ZL. Now, please note this point very clearly whenever we connect a ZL or RL. Okay. If we assume that it is a purely resistive thing, you can write it as RL itself. Then current flows to the load. Okay, so because what is the purpose of amplifier? You give one input, it is amplifier, and something is coming to output is coming to the load. Okay, so it should reach the load. Rishikesh ഇത്രയും താമസിച്ചത് എന്താ? Rishikesh, why are you so late? Okay, so the load current, you want the signal, amplified signal to reach the load. So the load current will be flowing outwards, whereas the output current will be flowing into the transistor. Actually, these two, I2 and IL, will be same in magnitude, but for analysis, you are showing. And now, who is that? Can somebody read out the name? Okay, I2 and IL are equal in magnitude but opposite in direction. Okay. So for when we analyze, we'll take IL is equal to minus of I2. So here, see the dotted line, where this dotted line is shown is important. And so that is just before the transistor, where we are applying the actual input. See, the external voltage Vs is given from the source, but some voltage will be dropping across Rs and the rest would be reaching the transistor port, input port. Okay, so that voltage is denoted as V1. And so you have some current flowing into the transistor. So when a voltage and current are there, some impedance will be associated with it. That is known as input resistance, Zi. Zi stands for input resistance. You can call it as Ri also. Please mute somebody. Who is that? Who is that? കാശിനാഥാണോ? മ്യൂട്ട് ചെയ്യൂ. So these portions are very important. Okay. I won't get time to repeat in class in offline mode. So take down notes properly. So V1 is the voltage that is actually coming across the transistor and current I1 that is flowing into the transistor. So V1 by I1 will result in an input impedance Zi, which is equivalent to Ri. So this is RL. And similarly, at the output side, at the output port of transistor, you have V2 and current is flowing. So you will have an impedance ZO. So that indicates the impedance of the transistor alone. So input impedance and output impedance. So if we have the biasing resistors also, it will include all those things. The only thing that is outside this dotted line is the external source on the input side, and at the output side you have the load. So Vs is the voltage at source and V1 is the voltage at input of transistor. These 2 points you need to remember. Now for a good voltage amplifier, Ri has to be much greater than Rs and ZO should be much less than ZL. So this we had discussed in class also. Okay, because how if we connect like this, you have Vs, then Rs is there, and this is where we have this Ri or the input of transistor. So the voltage coming across that is called V1. Okay, V1 or Vi. So what is V1? V1 is equal to Vs into Ri, input impedance of transistor, divided by Ri plus Rs. So what we would prefer is V1 and Vs should be the same. That means whatever you want to give from the external source, if that entire thing should be transferred to the transistor or the circuit. Only then it can be perfect. Say I am getting a 2 millivolt from the sensor output. So I want that 2 millivolt to be amplified by the circuit. If that 2 millivolt is getting divided by this Rs and Ri, and it results in 1 millivolt, means the circuit is not proper. It will not be proper because you are not getting the full input. So ideal voltage source would have Rs is equal to 0. But getting Rs is equal to 0 is not practically possible. So when you make a voltage source, then you have to design it with to reduce Rs to a minimum value. In your lab, you can see that function generator, our function generator, which is a source voltage, will be having written over that 50 ohms. It means the input impedance of our voltage source is 50 ohms. So when you design a circuit, you have to ensure that our input impedance. See, from this equation, how can you make V1 is equal to Vs? Either Rs should be equal to 0 or very small, or the next option is Ri is much, much larger than Rs. So if Ri is much, much larger than Rs, that is this condition we said. In that case, V1 will be almost equal to Vs. So if you are designing a voltage source, try to make the source resistance as low as possible. But if the source is not in our control, you have to use, in lab, you don't have an option. You have to use the function generator. Then what we can do is, you can make the input impedance of the circuit very large so that this condition is satisfied. So these things you should remember, that is ideal voltage source means Rs is equal to 0. Whereas in a current source, it's a Norton equivalent. See, the voltage source means it is a Thevenin equivalent. So the voltage and source resistance are coming in series. Whereas in a current source, it is a Norton equivalent. So the current source and the source resistance come in parallel. So here what you want is, you want the entire current Is to flow to the circuit and nothing should flow. Ideally, nothing should flow to the source resistance. For this to happen, source resistance should be equal to infinity. Again, that can never happen. So if you want to get maximum current from the source, the input impedance of this circuit, when you are using a current source, that should be as minimum as possible. When you design a circuit, and if you are designing a source, make Rs as large as possible. Now coming at the output side. At the output side, what we have? You have Z0, then that is R0, RL. You want maximum voltage to reach RL, means this R0 should be minimum, so that entire current will flow to the load resistor and you will get maximum voltage. So there you prefer to have Z0 much smaller than ZL. This is a Viva question. Okay. Here I have shown an example here. Okay. All right. So what you have to do in our syllabus is you have to derive all these things. So for that transistor, that box is replaced by the equivalent circuit HI, HRV2, HI is there, I1 is there, V1, and HFI1, HO into V2. All these things are there. I2 is shown flowing into the transistor and IL is shown as flowing out of the transistor. You have ZL there and Z0 is marked. Please remember this point. Z0 is marked before ZL because it means it is the output impedance of the circuit and it doesn't include the load resistance. Likewise, Zi is shown after the source resistance. So it is the impedance seen at the input of the circuit, not before the source resistance. So these points are important where you are seeing it. And look how we are showing the arrow. The arrow is shown like this with the arrow is pointing inwards. It means I am looking at the circuit standing at this point. And at the output side, again, I'm standing here and I'm looking at the circuit. So what is the voltage and current? That will give us at 0. Here I look into the circuit. What is the voltage I see? V1. And what's the current? Again, I see that is I1. So V1 by I1 will give input impedance. Okay. So when you have to derive all the parameters, always start with current gain. Okay, so that is the path you have to follow. First, that is why I put one here. First, you have to find current gain. So what is AI? AI means it is the current gain. It is equal to IL, load current, what I am getting at the load. IL divided by I1. I1 is my input current. And earlier itself, I told that I2 and I1, IL are same, but they are in opposite direction. So IL will be equal to minus of I2. So AI is equal to minus I2 by I1. Now we have that hybrid parameter equation already, which is I2 is equal to HFI1 plus HOV2. That is the first equation. And also, if you look at the circuit, then you can see that V2 and V0, they are parallel. So what is V2? V2 is equal to IL into ZL, but IL is equal to minus of I2. So I can write V2 is equal to minus I2 into ZL. Now substitute this value for V2 in the first equation. So I'll get equation as I2 is equal to HFI1 minus HOI2 ZL. So you group the terms, coefficients of I2, you will get I2 into 1 plus HO ZL is equal to HFI1. So what is AI? AI is equal to, current gain is equal to minus I2 divided by I1 is equal to minus HF divided by 1 plus HO into ZL. See, remember earlier I told how did we define HF? HF was also a current ratio. It was equal to I2 by I1. And under what condition? Output voltage is equal to 0, which means you have a short circuit there. And when will you get short circuit? When RL or ZL is equal to 0. Substitute ZL is equal to 0 here. The second term in the denominator vanishes. So you will get minus HF by 1. So that is equal to HF itself. So HF indicates the maximum current gain. Is that much clear? Do you have any doubts? Now, why do you get a negative sign here? Because actually current gain means it should be the current reaching the load. Okay, so IL divided by I1, and IL is nothing but minus of I2. That is why you get a negative sign here. Do you have doubts? Have you taken down till here? Please respond.
Yes, ma'am.
Okay. See, this will be asked for exam. Derive all these things. So AI, so the first thing you have to do is derive current gain. So AI is equal to minus of HF divided by 1 plus HO into ZL. Now the second parameter is input impedance. What is input impedance? ZI. And where is it marked? It is marked at the location of V1. So voltage that you are seeing is V1, and the current you see is I1. So ZI is nothing but V1 divided by I1. Again, we have H parameter equation, first equation as V1 is equal to HI into I1 plus HR into V2. So what is V2? We have already derived. So V2 is equal to minus of I2 into ZL. Now, from the current gain equation, you know what is I2. What is minus of I2? Minus of I2 is AI into I1. So substitute that. So you will get V2 is equal to A1 I1 ZL. Sorry, AI I1 ZN. That is current gain into input current into ZL. So output voltage is equal to AI into I1 means it is the magnified current, amplified input current coming to the load. That is the output voltage. Okay. So V1 equation can be written as HI into I1 plus HR AI I1 ZL. And what is ZI? ZI we have already defined it as V1 by I1. So divide throughout by I1, you will get ZI is equal to HI plus HR into AI ZL. Again, if ZL is equal to 0, so if you are short circuiting output side, then what will happen? The second term will go, and you will be resulting, and it will be equal to ZI is equal to HIE. Okay, HI. If it is emitter configuration, common emitter, then it will be HIE and HIB or HIC, whatever it is. So generalized input impedance equation is HI plus HR AI into ZL. Now the third parameter. Have you taken down? Yes. Yes or no?
Yes, miss.
Okay. So the third one is voltage gain. So what is voltage gain? Output voltage divided by input voltage. And output voltage is V2. V2 we have already defined it as current gain, amplified input current into load. So AI I1 into ZL. But V1 by I1, you have already derived it as ZI. So you can write this as AI into ZL divided by ZI. So the output voltage, the gain, voltage gain depends on what is the current gain, then what is the output impedance, output impedance and input impedance. All right. Is that much clear?
Yes, sir.
Okay. So earlier I told you that this H parameters will be given in the data sheet. So if we try to relate what is AI to HF, in this equation you can see that AI is equal to minus of HF divided by 1 plus HO into ZL. See, maximum current you are going to, current gain you can get depends on the transistor parameter HF. So that is why for applications, remember in RC phase shift oscillator and all, we had derived a condition that you should use HF beta of certain value, minimum value is there, because there is a limit on, you can't expect to get a high current gain with a low HF or beta transistor. They are related. So AV is equal to AI into ZL divided by ZI. So till now we were looking only from here, just outside, what is happening with respect to that yellow box. That means RS was not considered at all. So if you consider RS, you have to put a subscript AVS. AVS means output voltage by input voltage Vs. Now, why do you have to define such a thing? Because you don't know what, once you get a circuit, what we will do is from function generator, you select some voltage, say 40 millivolt. So the function generator will be showing 40 millivolt, and then you will be trying to find what is the voltage developed across the load resistance RL. Okay. So the user will know only that much. We are assuming that the circuit is inside a black box. You don't know. So you are giving some input and you are expecting some output at the other side. Okay. Actually, this entire input voltage Vs might not have reached the input side, because right now we know that Vs and V1 are not same. That depends on the source resistance also. Okay. But as far as users, we don't know that. So even if something happens, RS is very large, the entire input is not reaching the amplifier, and because of that, output developed at the output side is less. But what we assume is that circuit design is not correct. That is why output is less. It's not the problem of the amplifier circuit. It is because of the source resistance. But you have to anticipate that such a situation can arise. So when you design the amplifier, you have to make Ri or Zi much greater than Rs. If you take that precaution, you need not worry about this. Okay, so what is AVS? AVS is equal to V2, output voltage divided by Vs. And what is V2? V2 is equal to voltage gain into input voltage. Okay. So AVS is equal to AV into Zi divided by Zi plus Rs, because V1 is that. V1 by Vs. Earlier we had written. What is V1? V1 is equal to Vs into Ri or Zi. Zi divided by Zi plus Rs. Okay. That is what we have substituted here. Vs and Vs will get cancelled. So it is equal to, instead of V1, it will become AV into Zi divided by Zi plus Rs. Okay. So when you do that, and it is also AV is equal to, you can substitute this. What is AV? AV is equal to AI into ZL divided by Zi. When you substitute that, Zi will get cancelled and you will get AI into ZL divided by ZI plus ZS. Please note all these equations because you will get problems based on it. So you can quickly find, if you find ZI, AI, you can get all these things. You find AI and immediately you can find what is input impedance, and also you can find what is voltage gain. Now the last one is output impedance. So output impedance is equal to Z0 is equal to V2 divided by I2. Now we are not putting a minus sign. Why? Why no minus sign is there? Because Z0 means you are looking at the circuit standing at this point. So what you see is the voltage at that port is V2 and current flowing into it is I2. So we are not concerned about IL because you are standing before this ZL. So there is no negative sign. So Z0 is equal to V2 divided by I2 with RL is equal to infinity. Okay, that ZL we are not considering at all. Load resistance is open and Vs is equal to 0. See, this point is important.
Ma'am, Pranavum Varinum join ചെയ്യാൻ നോക്കുന്നു പക്ഷെ ആഡ് ആവണില്ല എന്ന് പറഞ്ഞു.
ഇനിയിപ്പൊ ജോയിൻ ചെയ്തിട്ട് എന്തിനാ? നിങ്ങൾ എന്താ ഇത്ര വൈകുന്നേ? വൈകിട്ടല്ലേ? ഇങ്ങനെ അറ്റൻഡൻസിന് വേണ്ടി കയറിയിട്ട് വലിയ കാര്യമൊന്നുമില്ല. See, please be careful about this subject. You won't be able to study on the eve of the exam. കേട്ടോ? ഈ അനാലിസിസ് ഒന്നും ലാസ്റ്റ് മിനിറ്റ് പഠിച്ചെടുക്കാൻ പറ്റുന്നതല്ല. അപ്പൊ സപ്ലി വരാതെ നോക്കണം. ഈ സെമസ്റ്ററിലെ എല്ലാ സബ്ജക്റ്റുകളും അങ്ങനെയാ. SSC ആണെങ്കിലും നെറ്റ്വർക്ക് ആണെങ്കിലും ഒന്നും തലേന്ന് പഠിച്ചെടുക്കാവുന്ന പറ്റില്ല. സിസ്റ്റമാറ്റിക് സ്റ്റഡി ഈസ് വെരി ഇമ്പോർട്ടൻറ്റ്. Okay. So what I was saying is, when you want to measure one impedance, what you do is you give voltage at that port and measure what is the current flowing into the circuit. Voltage by current will give impedance. At the input side, it is not confusing because you know that only if you give some input, output will be produced. So you are giving voltage there, current is there. Now, when you come to output impedance, there also we don't call it as output, or we are not bothered about that. What we are interested is you want to find what is the impedance at this port. So what you have to do, you have to make this 0. That means you consider this is not there. You are not applying any voltage there. You apply some voltage here and you measure what is the current flowing into the circuit. So you don't want anything after this also. That is why ZL is equal to infinity and Vs is equal to 0. So the simple rule is, wherever you want to measure impedance, you apply a voltage at that point and measure current flowing into the circuit. Okay. So Z0 is this, and Y0 admittance is equal to 1 by Z0. Now the equation you have already discussed, that is I2 is equal to HF into I1 plus HO into V2. So Y0 will be equal to HF into I1 by V2 plus HO. You are dividing the entire thing. How do you get this as Y0? You are dividing by V2. All the terms are divided by V2. So current by voltage, that will be equal to admittance. So I2 by V2 is Y0. H1 I1 divided by V2. H0 V2 divided by V2. That is how you get this equation. But I1 by V2, we have already written as minus HR into HR divided by RS plus HI. How do you get that? RS plus HI, how do you get this equation? Consider this input loop. When you consider this input loop and Vs is equal to 0, this is not there. Then what do you have? Around the loop, voltage should be equal to 0. So now the HRV2 is the source, only source available here. That means RS plus HI into H1 will be equal to HR into V2. That is what we have written here. RS plus HI into I1 is equal to minus HRV2. Only then around the loop voltage will be equal to 0. So from here I can write I1 by V2 is equal to minus HR divided by RS plus HI. So substituting that, we'll get Y0 is equal to minus HF HR divided by RS plus HI plus HO. So look at the equation. This output admittance will has all H parameters in there. You have to use all H parameters to find the value. So these problems we'll do next day. Take it as a homework. For a common emitter amplifier, for VC is equal to 0, that means V2 is equal to 0. When V2 is equal to 0, collector current is equal to 2 milliampere and in IB is equal to 30 microampere and input voltage V1 is equal to 50 millivolt. And when I1 is equal to 0, then VC output voltage is equal to 1 volt, V2 is equal to 1 volt, VB input voltage is 0.3 millivolt and output current is 0.1. Find all H parameters. Please take down the problem. Have you noted it down? When you finish writing, please tell me. I can't see if you put in chat box. Just unmute yourself.
Yes, ma'am.
Okay, thank you. Okay, so here I have summarized. You have to take down this table, the entire thing, whatever is in this slide, please take down. Common emitter configuration, current gain, input impedance, voltage gain, output impedance, voltage gain including source resistance, current gain including source resistance. Note it down. And what you have in yellow on the right side is how H parameters in one configuration is related to the other. For example, input impedance HIE in common emitter configuration is equal to input impedance is in common base configuration HIB divided by 1 plus HFB. HFE is equal to minus HFB divided by 1 plus HFB. See, this equation you have seen earlier also. Beta is equal to alpha divided by 1 minus alpha. Remember that equation? Do you remember that equation?
Yes.
So beta means it is the current gain in common emitter configuration, and alpha is the current gain in the common base configuration. So they are related. Okay? So take down these equations because you need to know this. H parameters in one configuration will be given. You will be asked to find current gain, voltage gain, etc. in another configuration. Again, when you finish, you tell me. Finished?
No, miss.
Make it fast. Finished. Okay, shall I change? Have you finished taking it down?
Yes, ma'am.
Now these are the sample values. See, in this slide, what we did is we were relating common emitter and common base. This is common emitter parameter in terms of common base. And on the rightmost side, you have common base parameters in terms of common emitter. And here it is a rough estimation of common collector and common emitter. Because common collector is normally used for impedance matching and buffer sort of thing. So not much importance is given to that. Now these values also you have to take it down and take down this problem also. See, this is a typical question. Maybe the numbers will change, but very frequently such questions are asked. So all of you have to do this. If you practice problems, then you can score full marks in that. Okay, we'll stop here. The next thing is we'll design RC coupled amplifier and discuss the frequency response of that. For that I require 1.5 hours. Don't leave, I'll take attendance.
മിസ് മിസ് ഞാൻ ഈ ക്ലാസ് വരെയൊക്കെ അറ്റൻഡ് ചെയ്യാൻ പറ്റിയില്ല. അപ്പോൾ എനിക്ക് ഈ സ്ലൈഡ്സ് കിട്ടാൻ വേണ്ടി വല്ല വഴി ഉണ്ടാവോ?
ആരാണ് പറയണേ?
അമീൻ.
അത് ആരെങ്കിലും എഴുതിയെടുത്തിട്ടുണ്ടാവും.
ഓക്കെ മിസ്, അങ്ങനെ നേരത്തെ ചോദിച്ചോ.
Quickly call names. പറഞ്ഞോണം. ആർദ്ര, ആരോമൽ,
Present, ma'am.
അബ്ദുള്ള ഹിലാൽ,
Present, miss.
അഭിജിത്ത്,
Present, miss.
അഭിനവ് കൃഷ്ണ, VV,
Present, miss.
അഭിരാം,
Present, ma'am.
അഭിഷേക് PS, ആദിത്യൻ M രാജ്,
Present, miss.
അഡ്നാൻ, പേര് വിളിച്ചവര് ലീവ് ചെയ്തോളൂ കേട്ടോ. അദ്രിജ,
Present, miss.
അതുൽ,
Present, miss. Present.
അഹന്യ,
Present, miss.
അജയ്,
Present, miss.
ആൽഫിൻ,
Present, miss.
അമൃത,
Present, ma'am.
അനന്തഗോപാൽ,
Present, miss.
അനന്തൻ,
Present, ma'am.
അനന്തു, അനൂഫ്, അനുഗ്രഹ്,
Present, miss.
ആരതി,
Present, miss.
ആർദ്രപ്രകാശ്,
Present, miss.
അർജുൻ,
Present.
അഷ്മി,
Present, ma'am.
അസ്രോൺ,
Present, miss.
ഭഗത്,
Present, miss.
ഭഗത് TP,
Present, miss.
ചൈതന്യ,
Present, miss.
ധാന്യ, ധീരജ്,
Present, ma'am.
ദേവദത്ത്,
Present, miss.
ദേവനാരായണൻ,
Present, miss.
ദേവാംഗന.
Present, miss.
എ ബാച്ചുകാർക്ക് ഞാൻ സാറ്റർഡേ ലാബ് വെച്ചിട്ടുണ്ട്. ഡോൺ ജോസഫ്,
Present, miss.
ദൃശിക,
Present, ma'am.
എൽനിയോ,
Present, miss.
ഫഹദ്, ഗോവർദ്ധൻ,
Present, miss.
ഗൗതം ലാസർ, ഗോപിക,
Present, miss.
ഗൗരി നന്ദന,
Present, miss.
ഹാദി മുഹമ്മദ്, ഹംദൻ,
Present, ma'am.
ഹനീൻ, ഹിതക്, ഋഷികേഷ്,
Present, ma'am.
എന്താ ലേറ്റ് ആയ?
മിസ്സേ ഞാൻ മുമ്പേ ജോയിൻ ചെയ്യാൻ നോക്കുന്നുണ്ടായിരുന്നു, പക്ഷെ അത് ചെയ്യാൻ പറ്റുന്നുണ്ടായി.
ഇസാൻ, ഇവാന,
Present, ma'am.
ജേക്കബ്,
Present, miss.
ജെയ്സി,
Present, ma'am.
വരുൺ, വരുൺ ജോയിൻ ചെയ്തിട്ട് ലീവ് ചെയ്തോ? ശ്രീലക്ഷ്മി,
Present, miss.
മിസ് പ്രസന്റ് മിസ്. മൈക്രോഫോൺ വർക്ക് ആവുന്നില്ല.
ഓക്കെ. ജ്യോതി,
Present, miss.
ഹൃദ്യ, പ്രണവ്,
Present, miss.
ഏബൽ,
Present, miss.
ജോയൽ, ജോൺ,
Present, miss.
Present, miss.
ജൂലിയ, ഓക്കെ. അനന്യ,
Present, miss.
കണ്ണൻ,
Present, miss.
കരീന,
Present, ma'am.
കാശിനാഥ്,
Present, ma'am.
കിരൺ,
Present, miss.
നാസിഫ്,
Present, miss.
മഡോണ,
Present, miss.
മാനസ്,
Present, miss.
മിസാം,
Miss.
അമീൻ, മുഹമ്മദ് ഹസൻ,
Present, miss.
മുഹമ്മദ് ഹസൻ, റനീം, ഷഹസാദ്,
Present, ma'am.
താബിഷർ അലി,
Present, miss.
റെഹാൻ,
Present, miss.
ഷാൻ, നവനീത്, നാസുൽ,
Present, miss.
നവീൻ,
Present, miss.
നീരജ്,
Present, ma'am.